In this physics flashcards, we will be discussing the Doppler effect. What is it and how do we use it in physics? The most easily noticeable example of the Doppler effect is observing a car or an ambulance pass. The sound of it approaching and leaving have two distinct sounds. The Doppler shift is the change in the wavelength of a wave due to your velocity relative to the object creating the wavelength. Okay, this means you can observe the change in a wavelength if you're moving towards or away from a source creating sound, or if a source creating sound moves towards or away from you. An easy way to visualize this is a stationary object that creates sound. The sound is visualized as a circle expanding at a constant speed away from the object. Each circle produced from the object is at an even time interval. If the object moves, the rate at which it produces these circles does not change. If the object moves to the left and continues to produce the same noise, the edges of the circle to the left of the object are closer together than the edges of the circle to the right of the object. This means the wavelength to the left of the object decreases and the wavelength to the right of the object increases. This happens because sound travels at a constant speed. Around us, the speed of sound is about 350 meters per second. If an ambulance is approaching you at 20 meters per second, the sound it produces still travels at 350 meters per second, but the distance between each wave decreases a little bit, and the distance between each peak of each wave increases as the ambulance moves away from you. Our ears are sensitive enough to pick up this difference in sound. Interestingly, light is also affected by the Doppler shift. Since light has a constant velocity and a wavelength, the same rules apply. For example, if a star is moving towards us, the light is Doppler shifted. As the star moves towards us, the wavelength of the light decreased. Since blue light is on the shorter wavelength side of the visible light spectrum, we often say that the star is blue shifted. The star might not appear blue, but it means the wavelength of the light is decreased. Similarly, if a celestial object is moving away from Earth, we say it is red shifted, because the visible wavelengths have shifted towards the lower red frequency of the visible spectrum. This is a key point in astrophysics. If you can calculate what the frequency of a star should be, and the observed frequency is, you can figure out if the star is moving towards or away from Earth, and at what speed. If an object is moving perpendicular to Earth, it would appear stationary, because the object would not have a Doppler shift. A difficult question is when observing a red-shifted object is pondering whether the object is moving towards or are we moving towards it faster than it can escape.